Unplugged with ARJ, gentle wisdom light your way. Evening thoughts soft and clear. Tune in now and bring it near. Calm your mind, let's begin. Unplugged with ARJ, where learning's within.
Welcome to your personal deep dive. Today we're going to be exploring the world of Python, specifically for data science. You've sent us some notes from what looks like a Python primer, and you want to know what the real gems are, right? The stuff someone already familiar with Python for data science would really focus on.
Exactly. We'll break down the essentials and highlight what makes Python so powerful for data science work. Think of it like we're going to translate these notes into a strategic understanding of, how and why Python is used for data science.
Love it. So let's get right to it. First question. These notes mention Python's popularity in the data science world. Is it really all it's cracked up to be?
It absolutely lives up to the hype, and there are a few reasons why. First, Python's syntax is incredibly readable. It actually looks a lot like plain English, which is a huge advantage when you're dealing with complex algorithms and data structures. It helps data scientists focus on the logic rather than getting bogged down in deciphering the code itself.
Makes a lot of sense. I've heard that Python is great for collaboration because of this. Is that true?
Definitely. When code is easy to read and understand, it's much easier for teams to work together. Data science is rarely a solo endeavor, so having a language that promotes collaboration is a huge win. And not only that, it makes debugging so much easier, which, believe me, is a big deal when you're working with large data sets and complex analyses.
Okay, so readable, collaborative, excellent for debugging. What else? These notes also mention robust libraries. What are they and why are they so important?
Imagine walking into a workshop with all the tools you could ever need, perfectly organized and ready to go. That's essentially what Python libraries are for data science. Instead of building everything from scratch, you have these pre-built sets of functions and methods that are optimized for specific tasks.
From instead of reinventing the wheel each time, you can just pull out the right tool for the job.
Exactly. And you have a library for just about everything in data science. Let's say you need to perform complex mathematical operations on massive data sets. You've got NumPy for that.
Okay, NumPy, got it. What if I'm working with data that's more structured, like something you'd see in a spreadsheet?
That's where Pandas comes in. It's designed for reading, cleaning, manipulating, and analyzing data that's organized in rows and columns. Pandas is really the workhorse of data wrangling and analysis.
And what about when you want to visualize the data, to actually see the patterns and trends? The notes mentioned Matplotlib and Seaborn.
Right. Matplotlib is your go-to for creating static, interactive, and animated visualizations. It's incredibly versatile and can generate a wide range of charts and graphs, helping you see the story hidden within the data. Seaborn, on the other hand, is built on top of Matplotlib and provides a higher-level interface for creating even more statistically sophisticated and visually appealing plots.
So Matplotlib is the all-rounder, and Seaborn is for when you want to take your visuals to the next level.
That's a great way to put it. And finally, for those really complex, specialized scientific computations, you have SciPy. It builds upon NumPy and provides algorithms and functions for optimization, signal processing, linear algebra, and a whole range of other scientific domains.
So it sounds like these libraries really cover the entire spectrum of data science work. But how do you actually organize the data itself within Python? The notes mention data structures, and they seem pretty fundamental.
Absolutely. Data structures are the foundation of how you store and manage your data in Python. We're talking about lists, tuples, dictionaries, and sets, each designed to hold and organize data in specific ways depending on your needs.
Let's start with lists. What makes them useful in a data science context?
Think of a list as a container that holds an ordered sequence of items. Like if you were tracking the daily closing price of a stock, that sequence of prices would naturally fit into a list.
And what's the advantage of using a list over just having the numbers floating around?
Lists give you structure and organization, and they come with built-in methods for adding, removing, or modifying elements. Plus, you can easily access individual elements by their position in the list.
Okay, now how do tuples fit into the picture? I've heard they are similar to lists, but not quite the same.
You're right, tuples are also ordered collections of items, but the key difference is that they're immutable. Once you create a tuple, you can't change its contents.
So why would you ever choose a tuple over a list? It seems limiting to not be able to change things.
Well, immutability can actually be a powerful feature in data science. It ensures data integrity. Let's say you have a set of geographic coordinates. latitude and longitude. These values shouldn't change, right? By storing them as a tuple, you guarantee that they remain fixed and accurate.
That's a great point. I could definitely see how immutability would be important in situations like that.
Exactly. Now let's move on to dictionaries. Think of a dictionary as a collection of key value pairs. It's like having a labeled container where you can easily retrieve information based on its unique label.
So it's like a real-world dictionary where you look up a word, the key, to find its definition, the value.
That's the idea. In data science, you might use a dictionary to store product names as keys and their corresponding prices as values. This makes it incredibly easy to retrieve the price of a specific product by simply looking up its name.
Got it. So far, we've got lists for ordered sequences, tuples for fixed data points, and dictionaries for key value associations. What about sets? They seem a bit more specialized.
Sets are all about uniqueness. They're collections that only hold one instance of each element. Imagine you have a massive data set with potential duplicates. A set would be an efficient way to quickly eliminate those duplicates and ensure you're only working with unique values.
So it's like a built-in filter for data cleaning. I could see how that would be useful.
Exactly. And they're also great for quickly checking if a specific element is present in the data set or performing set operations like union and intersection.
Okay, so we've got our data structures down: lists, tuples, dictionaries, and sets, all serving specific purposes in how we store and organize data in Python. But where does it go from here?
Well, now that we understand how data is structured, let's explore how we can work with it. And that's where those powerful libraries we talked about earlier come into play.
All right, libraries. Let's dive into some more specifics. Earlier, we were talking about NumPy and how it handles those massive calculations. What's the secret sauce behind its speed?
It's a really clever technique called vectorization. Imagine you're trying to, say, add two lists of numbers together, like element by element. In regular Python, you'd have to loop through each element and perform the addition individually, right?
Yeah, I can see how that would get pretty tedious, especially with huge lists.
Right. But NumPy lets you perform calculations on entire arrays at once, which is way more efficient, especially when you're dealing with large data sets.
So it's like adding a whole bunch of numbers to another bunch in one go, instead of 1 plus 1, then 2 plus 2, and so on.
Exactly. It's almost like having a parallel processing system working behind the scenes, crunching all those numbers simultaneously.
Yeah.
And to make things even faster, NumPy's core is actually written in C, which, if you know programming languages, C is known for being really fast.
So it's a combination of clever design with this vectorization thing and then a super efficient core written in C. No wonder it's so popular. Now, you mentioned pandas being the data organizer, especially for data that looks like, well, a spreadsheet. Why not just use basic Python lists or dictionaries for that? What does pandas bring to the table that they don't?
That's a great question. While you could technically represent spreadsheet-like data with lists or dictionaries, it would be, well, pretty clunky. Pandas introduces this concept of a data frame, which is essentially a much more powerful table structure. Think of it as a spreadsheet, but like on steroids.
Okay, so more than just the visual layout of rows and columns. What makes data frames so special?
They're specifically designed for data analysis. Data frames come loaded with all sorts of built-in functions for cleaning, transforming, filtering, analyzing your data. Let's say you're working with a data set that has missing values, which, let's be honest, is pretty common in real-world data. Pandas has methods to handle those missing values really easily.
I can see how that would be super helpful.
Yeah.
Dealing with messy data can be a real headache.
Oh, absolutely. And Pandas just makes it so much easier. You can filter your data based on specific criteria, select particular columns, or even group and aggregate data for more in-depth analysis. And you can do all of this within this intuitive data frame structure. It's pretty slick.
So pandas can really handle a lot of the heavy lifting when it comes to data manipulation and analysis.
It really is a workhorse for data scientists. And speaking of heavy lifting, let's move on to the visualization side of things. We mentioned Matplotlib and Seaborn earlier. Those are the tools that help us see the stories hiding in the data.
I'm really interested in this part. Data visualization seems so powerful, but I'm always curious about how it actually works.
Well, imagine you have a data set with, say, thousands of customer records, each with details like age, location, purchase history, all that stuff. It's really tough to make sense of that just by staring at rows and columns of numbers, right?
Yeah, it'd just be a jumble of information.
Yep. Exactly. And that's where Matplotlib comes in. It lets you create all sorts of charts and graphs to visualize patterns and relationships within your data. You could make a scatter plot, for example, to see if there's a correlation between a customer's age and how much they spend.
So it's about taking data that might seem abstract or overwhelming and turning it into something that our brains can actually grasp and understand.
Precisely. And then Seaborn takes it a step further. It's built on top of Matplotlib, but adds this layer of statistical awareness to your visualizations, so it can automatically highlight interesting patterns and relationships that might not be obvious just from looking at the raw data.
Okay, so with Matplotlib, you have a lot of control over the specifics of the plot.
Yeah.
And with Seaborn, you get more of a guided tour of the statistical insights that are hiding within the data.
That's a great way to think about it. Both libraries have their strengths, and honestly, they're often used together to create really compelling data visualizations.
Right, so we've covered NumPy, Pandas, Matplotlib, and Seaborn. Now, what about SciPy? When would you actually bring that into the picture?
SciPy is kind of like the next level. It's for when you need to do really specialized scientific or mathematical computations. It's built upon NumPy, so it also works with arrays, but it offers a much wider range of algorithms and functions for tackling those more complex problems.
Can you give us some examples of when you choose SciPy?
Absolutely. Imagine you're working on a project that involves optimizing a complex system. This could be anything, really, from finding the most efficient route for a delivery truck to figuring out the optimal settings for a machine learning algorithm. SciPy has all these powerful optimization algorithms that can help you find the best possible solution.
So it's kind of like having a team of mathematicians and scientists on call, ready to tackle those really tough problems.
That's a great analogy. It really is a treasure trove of advanced math and scientific functions that go way beyond what you typically find in NumPy or Pandas.
Okay, so we've explored these amazing libraries. But what about the process of actually writing code? These notes keep mentioning functions and loops. How do those fit into the whole data science workflow?
Functions and loops are like the building blocks of programming, and they're absolutely essential for making your data analysis code efficient, reusable, and easy to understand. Let's start with functions. A function is basically a self-contained chunk of code that performs a specific task.
So instead of writing the same lines of code over and over again, you can just package them up into a function and then reuse that function whenever you need to perform that task.
Exactly. It's all about efficiency and avoiding unnecessary repetition. For example, imagine you have a data set with dates, but they're all in different formats. Some are month, day, year, others are year, month, day, and so on. You could write a function to standardize all those dates into a consistent format.
Ah, that makes sense. And then you could just apply that function to the entire data set without having to manually fix each date.
Exactly. Functions are all about making your code more organized and manageable. Now, loops are a bit different. They let you execute a block of code repeatedly, but usually with some variation each time.
So like, if I wanted to calculate the average price of every product in my inventory, I could use a loop to go through each product, calculate its average price, and then move on to the next one.
You got it. Loops are super useful when you need to perform the same operation on multiple items in a data set, or when you want to repeat a process until a certain condition is met.
So functions are for packaging up reusable chunks of code, and loops are for automating those repetitive tasks. It's starting to click how all these pieces fit together.
And that's really the beauty of Python for data science. All of these components, the libraries, the data structures, the programming concepts, they all work together to create this incredibly powerful and flexible ecosystem for analyzing and understanding data.
It's amazing how, even seemingly simple concepts like functions and loops can just unlock so much power in data analysis. It's like having this set of instructions, but they can be executed with incredible precision and flexibility.
Yeah, that's a really good way to put it. Functions and loops are really the workhorses behind any good data analysis script. They let you automate those repetitive tasks, structure your code in a logical way, and handle complex data manipulations, all with, relative ease.
Okay, so we've explored those foundational data structures. We went deep into these powerful libraries and even touched on the elegance of functions and loops. I feel like we've put together a pretty impressive data science toolkit at this point.
We definitely have. And, the beauty of Python for data science is that it's constantly evolving. There are always new libraries and tools emerging all the time, kind of pushing the boundaries of what's possible with data analysis. It's a really dynamic and exciting field to be a part of.
It's like having a toolkit that's constantly expanding, getting upgrades with, new and improved tools being added all the time. So for our listener who sent in these notes, What does all of this actually mean for them? They're clearly interested in Python for data science, but how can they actually take this knowledge and do something with it?
It's about empowerment, really. Even without being a, hardcore programmer, just understanding these fundamental concepts of Python for data science, it unlocks a whole new level of data literacy. They can now have more meaningful conversations with data science teams, interpret those complex visualizations, and you know what, even start exploring data analysis on their own.
So it's like they've gained this secret decoder ring for the language of data. Now they can look at a data visualization and not just see pretty colors and shapes, but really understand like the underlying data, the statistical relationships, and the story that it's trying to tell.
Exactly. And from here, the possibilities are kind of endless, right? They could dive deeper into specific areas of data science that, really pique their interest. Maybe they get fascinated by machine learning and want to explore how algorithms can be used to predict future trends or, to make more data-driven decisions.
Or maybe they're more drawn to that like visual storytelling aspect of data and want to learn how to create really compelling data visualizations, the kind that communicate insights really effectively.
Absolutely. The key takeaway here is that this deep dive has provided a really solid foundation. They now have the knowledge and, the vocabulary to confidently go out and explore the world of data science and find what areas really resonate with them.
And the best part is they don't have to do it alone, right? Python has this huge and incredibly supportive community. There are tons of resources available, tutorials, documentation, online forums, open source projects, all designed to help guide and support them along the way.
Yeah. It's like having this global network of data enthusiasts and experts all ready to answer your questions, offer advice, and even collaborate on projects. It's a truly welcoming and inspiring community to be a part of.
Well, this has been a fantastic deep dive into Python for data science. We've broken down some of those essential concepts, explored these incredibly powerful tools, and hopefully sparked a bit of a passion for data in our listener.
Absolutely. And just remember, data is everywhere these days. And with Python as your guide, you really do have the power to unlock its secrets and transform it into meaningful knowledge.
Thank you for joining us on this deep dive. We'll catch you next time for another exciting exploration of the world of information.